Very happy to be back here. I was here 2 years ago, and I was just telling Jez there was an incident where, at the end of my talk that was mostly about Cassandra, somebody asked me a question about solid-state disks in Cassandra and on AWS, and they said, well, what if these disks wear out? And I thought, I don't care. I rent them from AWS. I don't have to worry about SSD wear out. Then I moved on. If any of you have seen Scott Hanselman do one of his keynotes in the last year, this has been turned into an enormous piece of performance art where he goes on about it for about 10 minutes. But it happened here on this stage. So I'm wondering what will happen from this time. Maybe someone in the audience will write a keynote. No, maybe it won't. All right. Okay, so I'm going to talk fast delivery. Hopefully I'll keep you awake since this is the after-lunch crowd. So who am I and what have I been doing recently? So this is really my summary of my career in the last 4 or 5 years. I've been baffling late adopters, and I do it as a service. So that's basically it. I was the cloud architect for Netflix. I was at Netflix for 7 years, and I'll talk a bit in a minute about what I'm currently doing. But what I've got next is all the different talks I was giving over that time, and what were the reactions to it. Back in 2009, Netflix said, we're going to go to the cloud. And most people thought we were just making stuff up. It was just, no way. But we ran some encoding, some non-customer facing stuff was actually running on AWS in 2009. Because we'd run out of space in our data center for movie encoding. In 2010, it moved on to, okay, we believe you are doing something in the cloud, but it's not going to work. And at the beginning of 2010, the very first piece of customer-facing code was actually running on AWS. By the end of the year, all of the customer-facing code was running on AWS. Basically, all of the user interface, the website, and the APIs for supporting TV-based devices. So that was kind of nice. And then there started to be a few outages and things like that happened in 2011. And Netflix kept running when AWS was down several times. And so people kind of got that in their minds that maybe this is useful, and maybe it does work, but it only works for Netflix, and Netflix is sort of a unicorn. We're a very, very unique thing, and no one else will ever build anything like this. So that was kind of the summary. That was the year that we took the back end of Netflix and moved it all to Cassandra and moved all that to the cloud and cut the links that were working back into the data center behind everything. So that kind of looks good. So we moved on a little bit more, and people said, well, it looks like it scales, it's highly available, it looks kind of interesting. We'd like to do it, in fact. It kind of looks like some things we'd like to have, but we can't get there from here. It's just too big a jump to get over. So in 2012, Netflix started aggressively open sourcing its platform, and I was sort of project managing that process, product managing it effectively, trying to get all of the different pieces out that would make a complete platform. I gave a talk yesterday afternoon on the 40-something projects that Netflix has. So last year, when I was going around giving roughly the same kind of talk, I ran into people that said, okay, we're using your code and we just need to understand it better. We're trying to get our heads around it. And I found a lot of people who had really started piling into the code base that we'd built. So that was an interesting set of progressions. And what I learned from the time I was at Netflix is that speed is the thing that you want to optimize for. Netflix is a small company with lots of really big competitors, and the way it was going to survive was by dashing around really quickly and not letting any of the big competitors kind of go and squish it, right? And the speed of development, in particular, of the product is a key competitive advantage that Netflix has. And it's still, from all the companies I talk to, it's one of the most productive companies in terms of you have an engineer, they can get more done in less time than almost anywhere else. I really have not seen anywhere that can go that fast. You do that by removing friction from product development. You take all of the steps out. And you do that with a high-trust, low-process environment where there are no handoffs between teams. You just self-service everything. That comes from a culture based on freedom and responsibility. That goes across the entire company. Everybody there has the freedom to do what they need to do, but they're responsible for the outcome, right? So if you keep making bad decisions and the outcomes don't look good, you've got a bit too much freedom. let's switch you out for somebody different, right? So that's the peril built into this system, is you have to have good judgment, you have to show good judgment, and you can assume that everyone else has good judgment. And there's a uniformly high quality of people in the environment. Now, to make it possible to concentrate on the things that really matter, you have to get rid of all of the stuff that is the same everywhere and doesn't really matter. So we call that undifferentiated heavy lifting. Things like running your own data centers, capacity planning, all of that kind of stuff, and a lot of higher level functions. So anything that we could get AWS to build us to do, we would use. And that was basically the idea. Now, as an architect, what I was trying to do was, rather than having an architecture review board where I said, everyone came in and we had projects and I had to approve everything, we didn't work like that. What I did was I tried to dig out the things that were working and spread them around and talk about them. So what I was really looking for was the simple patterns that worked, and then get people to build tooling for it if they weren't already, and to tell everybody to use that tooling, and then try to get people to not do the things that didn't look like they were working. So that was basically steering it, and an emergent architecture rather than imposing an architecture on everything else. So most of the architecture of Netflix is the work of a very large number of people, and I sometimes get credit for inventing things that were nothing to do with me. There are some parts of the architecture I had a lot to do with, but in general what I was doing was gathering all the good ideas and organizing them and explaining them back to everybody else. One really interesting way of doing that is to take your architecture, go to a conference like the GOTO conference, and present it to people. It has two good things. One is you get comments back to see whether your ideas are good. The other one is that other people in your company see that you did a talk, read the slides, watch the video, and it's actually a very strong way of influencing what happens in your own company. Because words that are published outside have 10 times the weight of you sending an email internally, just the way people's minds work. Like if you write something in a book, and you say it to people, and you write it in a book, the book carries more weight because it's written on bits of paper, and you went through the process of doing that. So things do have more weight. And then the other thing I learned was that you can do impossible things instantly. You can take cloud and just use it to speed up the way you currently do stuff. Take whatever you did in your data center and just implement it more quickly, and sort of copy what you did. But the interesting thing is when you do something that you wouldn't dream of doing in your data center. Let's say, I think we need to try putting 50 machines in Brazil for a few weeks to see if that works. Right? Let's go hire an entire team in Brazil, ship some machines there. That's not happening, right? You fire up some machines on AWS, takes 10 minutes, you try out whatever you wanted to do, you shut them down, you're done, right? You can try infrastructure experiments on a global scale from just your laptop here without involving anybody else. That's incredibly powerful. We also created a 200 terabyte solid-state disk distributed database. Now, 200 terabytes of SSD was created as we were walking out of a meeting and I said, we really need to benchmark this. So we went and set up a machine. Or actually, the other manager went by an engineer's desk and she created it in 20 minutes. Right? That was in 6 data centers on the East Coast and West Coast of the US, and it was just provisioned. And then we did some benchmarking for a few days, then we shut it down again. Right? So don't, if you have an IT ops department, go and ask them for 200 terabytes of solid-state disk sometime and see what answer you get. Right? We do have a large enough Amazon account that we could get 200 terabytes of SSD on it, so that may also be a problem. All right. So what's happening out in the rest of the world? Well, this is what enterprise IT looks like. This is from Simon Wardley. First of all, they ignore things, and then the rest of the world starts to adopt it, so they say no. They think of things like iPhones and any other technology, basically. And then the rest of the world really starts doing it, and they say, I said no, damn it. And then, oh no, and then, oh crap. Now we have to do it. So Netflix was really a bit ahead of this. So in 2009, we were really ahead of the cloud. The rest of the world started catching up and copying it, and the big old enterprises were still going, no, 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 we don't want to do cloud. Well, what's happening now is we are actually at this point here, where enterprise IT is sort of colliding with cloud. So here's my Twitter icon. It's a cloud unicorn. And this is where I am now. Basically, I have a new job, and it's really at this point where enterprise IT is trying to adopt cloud and continuous delivery and DevOps and update all of their systems because of mobile and Internet of Things and competitive pressures of trying to get stuff done quickly. And all of these things are causing enterprises to sort of go through a huge upheaval, and there's a massive investment going on as they retool everything. So that's interesting from a venture capital company where I work now. They're trying to figure out which startups are going to be the ones that make a lot of money in this new wave of technologies. The timing was good as well. So, because this is, maybe a year or so ago, enterprises were kind of still tinkering around, doing experiments, but a large number of them have, over the early part of this year, they adopted Amazon as a primary supplier, a strategic vendor, right? So you get this list of strategic vendors. You've got IBM and Oracle and Microsoft and VMware maybe. And then you now have AWS as a strategic vendor for most enterprise IT companies. And that is a huge change because now they haven't necessarily finished their rollout, but they are on the way. So this is what's really going on here. This has been the year. 2014 was the year where enterprises just got over it and actually started building cloud. So what happens when you start disrupting things? There's a problem here, and this is a good summary for it. Lots of people have said this. I think Mark Twain said it as well, but what the quote thing said that Will Rogers said it first. So it isn't what you don't know that will give you a problem. It's what you know that isn't so. It's the things you think you know that aren't actually true. And the problem with incumbents and enterprises is they think they know things, but those things aren't true anymore. And that's where you get the opportunity as a startup or somebody with a new idea to come in with a different assumption. So this is really what separates the incumbents from the disruptors. It's the assumptions they make, and it's the optimizations they have in their business model that they base on those assumptions. So you optimize your business model on the way the world looked 5 years ago, and you have multiple billions of dollars of revenue, and you say, well, why should I do this thing over here? Because there's no money in it, right? But it turns out that those things that have no money, have a lot of developer adoption, they're going to be the next wave of applications. So let's just look at one assumption. This is the assumption that process prevents problems. If anything ever goes wrong, let's have a rule that says you're not allowed to do that anymore, right? Let's have a process step, and let's have a gate and a check, and so you get your company HR manual is basically a selection of scar tissue. It's like everything that anyone ever did wrong is somewhere in that HR manual. And your development processes are every time anyone crashed or blew up production or anybody complained about something, you'll have a rule that says you can't do that anymore. So you get these scar tissue that slows you down. If you see some, an aging athlete, right? Somebody who was an athlete in their 20s, you look at them when they're 40 or 50, they can barely walk, right? They are so covered in scar tissue, their joints are worn out, they're just too slow. So what you have to do is build processes that don't have that scar tissue. So how do you do that? Now, there's sort of two groups in the audience, I assume. There's probably a few of you working for sort of startup-y, fairly aggressive companies that are doing agile and are on the bleeding edge. And there's a few of you working for big old companies, enterprises, banks, government departments, going, this looks like Adrian's an alien from another planet. So this is the book for the people that need to convince their management. Who's read this book? People? A few of you. This is a novel. It's actually a horror story about DevOps, basically. It's about a company that's about to go out of business, and it's just a story. This guy turns up to work one day, and his manager and the CIO have both quit, and he's now the senior ranking guy in IT, and he says the CEO wants to see him, right? Oh, by the way, Wi-Fi is down, and they've corrupted payroll, and the developers and the security team and the operations people are basically having pitch battles, right? So pretty typical of a large enterprise. And the first half of the book gets worse and worse. At some point, the security guy basically loses his mind and goes around. They find him drunk in a ditch somewhere. So, but the second half of the book gets better due to the magic of Kanban and DevOps and all those cool things. Anyway, So let's look at this process. What does product development process look like in a big enterprise? Well, to make sure nothing can go wrong, you have a waterfall. You have, I have business need, and to ensure that I really do have business need, I will write documents, and I will spend weeks writing these documents, and then I will go and have meetings with management and spend weeks finding a time when all the managers can get in one place to actually look at these documents and make some arbitrary set of decisions. And then you have to go and argue with some vendors and buy some hardware. You've got to develop, actually, it's probably about 2 days worth of software development somewhere in this year-long process. But it takes weeks to write the specs, and then you deploy it, and it keeps getting problems, and you go back and forth. And then finally the customer says, it sucks, we hate this. And you go back to the beginning, and you find that the product manager is no longer there, the development team's working on something else, and there isn't any sense of iteration here. You've got this thing. You have to start a completely new project and justify it again to fix the thing and do it again. So quite often they don't get fixed. So you end up with bad products. So let's see if we can speed this up using a little bit of cloud as well as some slightly better processes. So let's take a piece out of the middle and chop that out and say we're just going to go straight from business need to developing the software. And this is kind of a typical, 2-week to 4-week sort of agile process, sort of Scrum-like thing. So the product manager works with the development team. They develop some code. That gets given to QA, who integrate it, the work from all the different members of the team. Operations stick it in production, and the BI team measure whether it worked. And you can get around a loop here that actually is reasonably productive. So now it looks like this. Maybe it takes a few weeks to go around this loop. But when you get back to the beginning of the loop, the product manager is still there and the developer is still there, and you can actually get little course corrections in there. So that's really the key thing. And to do that, you use, clouds, either public, private, whatever. Although Eucalyptus just got bought by HP, so I had to change the logo on that one. I have to keep updating my slides as people keep buying other people. But there's this section in the middle here that's still pretty slow. So let's try and speed that up. And instead of just working at the infrastructure level, let's try and work at platform level. So we'll replace that with a platform cloud. And now we're basically doing continuous delivery at this point, because we now are developing features with a developer using a platform, and you can go around this loop much more quickly. You've kind of got rid of the handoff to operations, because operations operate the platform, but there is APIs for the developer to use the platform, and that's what a platform as a service is, really. Think of Paas as developers that no longer need to talk to operations people to get their work done. You've removed a bunch of handoffs. So this is much quicker, and this is kind of what how Netflix works. So you have your feature development. You use Heroku or Cloud Foundry or Google App Engine or Netflix open source projects or Apsera or Docker or Continuity, except that Apsera just got a major investment, and they're sort of kind of owned by Ericsson now. And Continuity just changed the name to Cask for some reason. I'm not quite sure why. Continuity is a Paas for big data development. It's sort of HBase and Hadoop as a service. Okay. But if everyone's building the same apps over and over again because everyone has the same HR problems and the same kind of stuff, then why build custom versions of them? So we can replace this with Saas, or Business Process as a Service, and we can move along to we have a business person, doesn't need to talk to a developer, say a sales rep, fires up Salesforce, enters his information into it, now he has an application. And there was no developer involved in the thing. So think of Saas as the business end users that don't need to talk to developers, and they can get stuff done in minutes. You can get stuff, minutes, seconds. If you change it, it's hours, whatever. Salesforce is the best known one of these. One of the companies I've been working with, because Battery Ventures has invested in them, is Mendix, which is sort of business process app builder. Platfora is a big data sort of build it yourself by the analysts. But there's thousands more specific ones. So let's just summarize going around this loop. We want to do continuous delivery and get around this loop as fast as possible. So to start with, we're going to try and innovate faster. So we're going to want to measure customers, see the land grab opportunities, see competitors make a move you want to respond to, and see customer pain points, things they're having problems with. Maybe your customer service team says, well, we had 4 or 5 customers hit the same problem this week. So you go and figure that out. And then you want to analyze what to do about it and model some hypotheses about different remedies, different options you could put in there. That's really where big data comes in. I want to answer a question that nobody has asked before, and I want to answer it as quickly as possible. So that's what I think big data, the value big data brings to an organization. That's why Hadoop is good. It's a lot of unstructured data. You can just make your cluster bigger until you get the answer soon enough. The next thing is plan a response. Just do it. Tell other people you're doing it, because this is just a feature, and this is just a developer, and we didn't have to go and ask management for permission to roll this thing out. So that's the culture getting out of your way. And then finally, use cloud to deploy incremental features. They get automatically deployed around the world, and you launch an A/B test to see if this new thing is better than the old thing, typically. Right? So then you measure customers again, you go around the loop again. And when I gave this last week, Jez pointed out that the actual OODA loop doesn't just go around the loop in one way. So we've got a few more places. Occasionally, while you're orienting, you go back to observing, and when you're deciding, you go back to orienting, or you go backwards from there. So you go back and forth a few times. It isn't just how fast you go around the loop, it's how fast you navigate through this sequence and get something done. But the act part is where you change the customer experience, and you want to do that as quickly as possible, but also by going back and forth here, make the best decisions. So what does that look like if you have a small team of developers? This is kind of a typical thing where you have a release plan, you have a bunch of developers, and the QA team integrates it, and then ops replaces the old with the new. That's a pretty standard monolithic deployment. The problem with it is that if you get a bug found in QA, it blocks the whole release. You have to go back. One of the developers broke something, so they have to go fix it. All the other developers' code doesn't move forward yet. And then you get to operations, and they try to roll out the new release, and it doesn't work, and they have to roll back. And they roll back all the work of all the developers just because one thing was broken. And this gets worse and worse. If you have 100 developers, one developer can block 99 of them, because you've got to wait for everything to be ready, and you keep rolling back and forth. And it gets harder and harder to get through QA. It gets harder and harder to get production to work. So everything takes longer. So what people generally do here is they just make the release cycles longer because it's painful. So we'll do it less often, which is the wrong way around. What you want to do is do it more often. But what you can do, this is the best way to start. If you've got a small number of developers and you're just building a little monolithic app to get something done, you're iterating on your business model, you haven't figured out what you're doing yet, this is the right way to start. But at some point, you have to scale up a bit. And that looks more like this. You have several product managers, and you have several release plans, and you have developers working in different languages, each building independent systems that are deployed separately. So here they're all randomly deploying whenever they're ready. They're using some kind of container to just wrap it up. So your platform knows how to deploy a Docker container. I don't care whether that Docker container has Go in it, or Ruby, or Python, or PHP, or whatever, right? Or Java, it doesn't matter, right? But so your platform just automates that. But the other thing is the old release is still running. I'll come back to that in the next slide. Now you get a bug in this piece, the bottom one, and we just redeploy that one. But the rest of the system was already out there. So a bug in one developer's microservice does not block the others. So this is why microservices are interesting. This is why they're starting to get some traction. Partly that the tooling for it is getting better. Docker in particular is helping promote the idea. And also it scales with large teams. Netflix now has sort of 500-600 engineers. And you can't do a monolithic deploy with that many engineers. It's just too big. The other thing is more diverse platform. You want to basically try out new technologies, and with the monolith, it's harder to do that. So I'm going to go look at the non-destructive thing here. So this is sometimes called the immutable code pattern. You develop code, you do a build, you put it in production, and you never update that machine again. That container is just running. And the only thing you ever do is delete it and replace it with a new one, right? This is very different to the model where you use Puppet or Chef or whatever to change stuff in production. Now, they're obviously configured, and there's data that changes in them, but the key thing is the code is immutable. You route traffic around to make sense of what's going on. So there are A/B tests, there are feature enables, there's version routing. You could have 10 different versions of a service in production at once and just route different different flows of traffic to different ones to get the different behaviors. That means your traffic routing system gets quite complicated, but there are tools for doing that. And the Asgard console from Netflix basically automates dealing with all of that for Netflix developers. So that makes it quite easy. So the first person to use, so this is basically testing in production. You stand up a new service and nobody's talking to it. So you're safe. I could stand up a completely broken piece of code in production with no impact to anybody, right? That's safe to do that. And then I connect to it, see if it works. If it works for me, maybe the product manager has a look at it. If he likes it, then turns on a test cell, and 50,000 customers will see the new code and compare against the old code, and everything sort of moves forward. So that's the kind of tooling that's built around that. Finally, you remove the old versions and give everyone the new code. So what are we trying to do here? We're basically speeding up change by reducing the cost and the size and the risk of that change and doing everything much more often. So that's the key thing. And this is very disruptive. A lot of big companies are finding that their competitors are doing things in this way, and they have to keep up. And it doesn't give you sort of 20, 30% improvement. It gives you 100x. Things that used to take 6 months are done in a couple of days. Things that, it's ridiculously quick once you get everything else out of the way. And that speed is now the benefit, because the cost of software development isn't really that high. The cost of hardware isn't really that high historically. The cost of delaying your product's entry in the market is far higher. That's the trade-off that's being made. If you can get a product to market a month or two earlier than somebody else, you can capture a market. And that's really the powerful value. And the cost of doing it is something that comes, you get a much more revenue to pay for things. Okay, so I talked a bit about microservices, so let's do a quick definition on that. Loosely coupled, service-oriented architecture with bounded contexts. A lot of people say it's just another SOA. We've seen SOA before. It's old hat. Well, what do I mean by loosely coupled is that, let's look at it backwards. If you have to update all your stuff at once, it's not loosely coupled, right? Loosely coupled means I can update any individual microservice independently of the others, and that is what gives you the ability to roll forward rapidly at different paces. Some people are updating once a day, some people are updating once a month, whatever, doesn't matter. And the bounded context comes from domain-driven design by Eric Evans, who, if you've been to enough of these events, you've seen Eric give his talks. You become incredibly productive if you only need to know a little bit to get something done, right? I don't need to understand the entire system to make my piece of it work, because I can write a microservice that uses the language I know, and it has interfaces to things that I know about that are around me, but I don't need to understand beyond that. This is the same way that applications are developed. Think of developing a mobile app where you're using lots of external services. You're typically talking to sort of the Facebook API and the Google API and the Twitter API and all these different things. And you don't get to go and have a conversation with Google about the Google Maps API. You just use it, right? So all of the other teams in your organization become like API-driven in the same way that external companies are API-driven. So you just need to know how to use them. You assume they're stable, but you assume they might go down occasionally, so you put a bit of defensive code in there, right? So that's, when you get into this bounded context and it's just one or two people working on a very single function piece of code, you can build it incredibly quickly because you don't have to interact with lots of people. You don't have to learn too much to get productive. So how are we doing this? We're separating concerns with microservices. And a lot of this comes down to the way you organize your company. You've got to build a sort of, the DevOps approach is to build an end-to-end team that owns everything about a particular service. So in the microservice, you'd have a product manager or maybe a line manager that owns that service. You'd have the developers, and you'd have the people that run it in production, are all part of one team, and that's the only thing they do, right? So you build your company by using Conway's law backwards. You basically lay your company out in the way you want your code built. So you assume each team will build some number of microservices, and typically each engineer will build a series of microservices. And that's so you get your software architecture and you put it in your organization chart. So the other thing is that microservices is not really about micro meaning size, it's meaning micro function. Just they do one thing at a time. And you can do your own build. I don't really care what the container is. Netflix has been using AMIs as containers. That's just because a few years ago that was the best thing we could do. I think nowadays Docker's the right container. It does things in seconds that building AMIs will take minutes to do. And the other thing is cattle rather than pets. Have people heard that analogy? Let's just go through it a bit. So I left home about 4 weeks ago, and there's a cat at home. That's my pet, right? I think it's still alive. My son's been looking after it. He's pretty grumpy when we get back. But, I care about that individual cat being alive, right? So if there are machines you have in production that have a name, and when they go down, everyone gets unhappy, that's a pet, right? That's a pet machine. Now, on the other hand, somewhere out there is a herd of cattle that I'm getting milk from, right? Gallons of milk. And a couple of the cows die one day. I still get gallons of milk. Slightly fewer gallons, so I go replace a few of the cows, and then my gallons come back up to where I expected, right? That's a very different thing. Now I have a named herd where every element in the herd is just a numbered animal that's somewhat disposable. So that's the deployment model here. You deploy a large number of disposable ephemeral instances that together provide a service that is very resilient, and any individual member of that service can go away and everything will keep working. Okay. And that even applies to the stateful layer. The Cassandra layer uses ephemeral instances at Netflix. We use onboard disks, and they can die and they get replaced, and it's all automatic. So this is the sort of just summary. I gave a talk yesterday, 2 sessions on NetflixOSS, so I won't go spend long on this, but it's an entire platform for working in this way. And there's new projects coming out all the time. Some of them are big data, some of them MySQL, NoSQL based, some of them based around cloud, and there's all different use cases here. So it's not all AWS specific. But this is all open source, and there's a very important principle here that open source ecosystems have become the best way. It's the best code you can get, it's the most scalable code you can get, and the best people in the world are working on it. That didn't used to be true. 10, 20 years ago, the best people in the world were working at sort of IBM Research, working on relational databases or Oracle or whatever. The best people now are working on these open source projects, and you can get their code for free because they work at places like Google and Twitter and Netflix or whatever. You also think of GitHub being your online resume and also your company's online resume. And one of the reasons Netflix put out so much stuff on GitHub, it acts as an attractor for developers. And a lot of really good developers have joined Netflix because of its open source program. You're trying to build an ecosystem. And the other thing is you give up control to get ubiquity. Apache license is the right license to use if you're trying to work in this way. There are other licenses where you get more control, but you'll find your code just doesn't get traction. Okay, let me see what time I've got here. How much more time have I got?
15 minutes.
15 minutes, okay. All right, so when you're developing microservices, there's an argument that always comes up about the interfaces. And should you have a client library for it or not? And you get quite heated. Some people say, no, every interface should be self-describing, and anyone can use any language to talk to it. And other people say, no, you should have a client library for it. So my observation is that you'll end up with a library, because as soon as somebody writes some code that talks to your service, they'll give that code to their friend, and that code will wander around, and it'll end up being the standard pattern. So build it from the beginning. Own your own client libraries, and your interface to your code is the client library, not the protocol. You're going to end up like that anyway, so you should just start that way. Okay, so the other thing is that when you call a service, it's going to try and call lots more services, right? So you've got fan out of maybe 10 things you need to call. We can't call them in order. You don't know what order to call them in. You want to call them in parallel, so they have to do threading or maybe callbacks or whatever, right? It's a big messy thing. You get futures, then you get futures embedded in other futures, and it just gets messy. So RxJava, the reactive thing, which is, I think there's been some talks about it, there's conferences about it now, basically is a very clean way to solve that problem. It makes everything into an observable, and behind that observable you can implement it any way you like, but it means that the code, the business logic code, is working at a very high level, saying, I wish to observe the results of these things, and I will compose them, once they're all ready, I will compose them together and return it. It's a very nice way of looking at it. And then the other thing is that if a service breaks, one of the dependencies breaks, you want to be able to wrap that dependency in something that can be a bulkhead and a circuit breaker. So this is another patterns from the Michael Nygaard's Release It book. So you want to say, if it's broken, I don't really trust this code, I'm just going to stop calling it for a while and wait for it to get better. And once it's happy again, we'll call it again. We'll call it occasionally to see if it got better, but generally speaking, you'll turn this thing off. So there's a few ways of doing that. There's some Twitter mechanisms and some Netflix tools for doing that. And Hystrix is being adopted outside the Netflix ecosystem. I think the Scala Akka system is now using it. There's a few people. It's sort of broadening out beyond the core system that Netflix built. Now, if you've split everything into microservices, but they all talk to the same database, you discover that you have to update them all at one time because they're still coupled, right? I was talking about loosely coupled microservices, and if they all talk to the same database, they're not loosely coupled. So you actually have to split your database up, and this is where the computer science purists have to kind of, I don't know, get over it or something. You have to denormalize everything. Instead of all those things where they taught you how to normalize everything in school, well, you have to forget about that and denormalize everything, and you end up with this big, messy, inconsistent pile of data sources. But because every microservice has its own specific data source, it can be updated and developed independently, and it's very low coupling. So you can go faster. It's messier, but you can go faster. And you have to build tools which will rummage around in your system and keep all these data stores in sync. And you had to do that anyway as soon as you had more than one database, so it's not that unusual. One of the neat projects that we built at Netflix was we had so many times we would build a service in front of a database that we just built a standard one, and it's called Stash. So that's storage tier as a service over HTTP, Stash with 2 A's in it, right? As opposed to the Atlassian version that has 1 A in it. It does something completely different. The one that Netflix built has MySQL and Cassandra, C star is Cassandra, and from a single code base. You can actually use this as a migration tool if you're trying to migrate data sources from, say, a big MySQL schema, and you're trying to split pieces of it off into Cassandra. You can use that as a mechanism. And then you have to really get used to distributed systems. And I'm a physicist, so I'm kind of, my physics degree tells me that there is actually no such thing as consistency anyway, due to Einstein and relativity and all these things. So I'm actually more comfortable with that. But it seems like a lot of people really, really want their systems to be consistent, and there isn't really such a thing. There are just a few ways to fake it, and depends how well you're faking it and what happens when the faking breaks. That's really what happens. That's really what the discussion's about. And if you look at Afair's, actually Kyle Kingsbury, who's known as Twitter as Afair, he has a series of tests for databases known as the Jepsen series. Carly Rae Jepsen, Call Me Maybe, that's the song it's based on. And he systematically tortures to death just about every large-scale distributed system you've ever seen. So definitely worth seeing. So let's move on a little bit. You've built all these systems, but you've got to monitor them, and they look a bit different to monitor. The problem here is that there's a high rate of change. Right? Your machines are coming and going, they're auto-scaling. Maybe at midnight there's 100 services, and at peak traffic there's 1,000 of them, so it comes and goes every day. Code pushes cause floods of new machines. So your monitoring tools tend to die under the weight of new machines coming and going, and new metrics coming and going. So it makes it difficult. If you've got hand-tweaked Nagios servers, you're going to go crazy trying to keep this stuff up. So you have to build something that automates it. So the act of launching something in production causes it to appear in your monitoring system automatically. And that's the only way you can do it. And the other thing is you've got these end-to-end calling patterns where microservices call other microservices, and you need to capture the request flow. So in all of your requests, you throw an extra GUID in the header, and you pull these out and log them, and then you can actually take any one request and you can track it through the entire system, the tree of requests as it spreads out and returns back in. So that's the Netflix platform has all that built in. There's a number of ways to do that, but it is built in. Then you try to visualize these and they get overwhelmed. There's no good way to visualize hundreds and hundreds of services. So how many microservices should you have? This is from Gilt Group. If anyone's used Gilt, it's an online shopping site. And this is, I think, about 1 year's worth of development from adopting microservices, and to roughly the end of last year, they were just adding new ones, like several a week, and they got up to 450. And then they said, well, this is our diagram of how our microservices talk to each other, and there's only 12 of them. So I'm not sure where the other 438 went. But if you include the other 438, it looks something like this. This is the Netflix architecture diagram as of a couple of years ago when it was still fairly simple. And this is the Twitter version of the same thing, which is using Finagle and all of their visualizations. So it's quite a nice one. This was App Dynamics basically losing its mind as it tried to keep up with everything. So if that's your architecture diagram, how do you deal with this? Well, for any one service here, you grab that one service and you can see who's calling it and who it's calling. So for just the bounded context that you actually care about, it's no problem. I have 3 consumers, I have 10 dependencies. I'm done. I don't care what the rest of the world's doing. That is my world, right? I have security groups set up so only those 3 people can call me, and I know who I call. I'm done. So you get this bounded context, and every team works in that bounded context, and it's only at the aggregate level that everything has to actually work. So, okay, so continuous delivery. You're making these changes, they're small but they're frequent, and any one individual change is more likely to be broken because it's actually got less impact. So you're throwing code out there and seeing if it works. But when the change hits a customer, it's not usually new code. It's not a code push. It's a feature enable. It's flicking that switch on that enables this feature for all customers is when you go, whoops, I didn't mean that. I need to turn that off again, right? Now, if you hit that on switch and you look at your monitoring system and you get these 1-minute updates and you wait another minute, and it's still showing you 5 minutes ago. So you have to wait 5 minutes. And then finally you see a thing that looks bad. Well, it's only 1 data point. Wait for all that. I've got 2 or 3 data points, right? Well, what actually happened was you didn't bother waiting 5 minutes. You went and got a cup of coffee. Standing by the coffee machine, chatting to some people, and you suddenly realize everyone else is running around because the site's down. And then you finally realize it's because of what you just did, and you have to rush back and turn it off, right? So that happened a few times at Netflix. So 2 things. One is that there's a central monitoring system that collects all of these toggles, and whenever you change a production variable, it's logged centrally. So that's the first thing we did. And then we realized that wasn't sufficient. You have to remember the old setting of the value. You can't just say, variable A is set to 3. You have to say variable A was set from 2 to 3, so that when you switch it, you can switch it back to what it used to be. So you have to build that. And the other thing we did was build stuff which worked by the seconds instead of by the minutes. And this is what the Hystrix Turbine circuit breaker looks like. This is a JSON-based web page that you get by connecting your browser directly to your microservice. There's no intervening system. Your browser, you go to a URL that's connected directly to your microservice. It pushes this page directly into your browser, and it's updating continuously. It's a WebSocket. It's just pushing JSON over a WebSocket. So this thing is changing second by second. It's 30 seconds of history. These things are wiggling around. These numbers are all changing. It all looks fine. And then you flick a switch, and it goes, oops, you can't get your history bookmarks anymore. This is broken. You broke a dependency, and you go, oh, whoops, okay, let's flick that switch back off, and then it goes back to that again, right? So that's what you want. You want it to be like 10 seconds, which means you don't have time to go get coffee, right? You just got to sit there and wait 5 seconds for the data to flow through. Okay, so there are a few tools out there which actually do 1-second monitoring. So just want to highlight them to try. I'm trying to encourage all vendors to have at least part of their data collection at the 1-second level. Vivid Cortex is a MySQL monitoring tool. You can see here it's seen a 1-second long spike in MySQL latency, and here's a boundary which is 1-second-based data, second-by-second collection. They both actually look at the network layer and make sense of that. But go think about that. So what I'm basically saying is your metric to display from something happening to you be able to see it needs to be less than, say, 10 seconds, less than your attention span. Okay, so to summarize, what I'm really talking about here is old stuff, right? Separation of concerns, but separating concerns along project basis. You have microservices that implement features that are parts of a system. And each of those features is a separated concern and a bounded context. Rather than saying, my SAN admins separate their concerns from my sysadmins and separate their concerns from my DBAs, and you have to do handoffs to work your way through the operations team. That's the wrong kind of separation of concerns. That may be more efficient, but it's too slow. I mean, what you want is to have a team that is responsible for getting something done. And that is what makes it go fast. All right, so a few things, just looking forward, what's happening next? I now work in a part of the industry where lots and lots of things are coming through. I'm seeing all these companies with ideas and seeing what's happening. So what I'm seeing is that almost all the new things that I see are written in Go, and I have my Go t-shirt on today, just because it's a cool t-shirt. And I'm at a developer conference and I can wear a cool t-shirt. Docker's written in Go. Cloud Foundry is being rewritten into Go from Ruby. Apsera's written in Go. Vivid Cortex is written in Go. So these are large, complex SaaS platforms. They are, bits of tooling. There's an awful lot of stuff. And there are still a few things written in other languages coming by. But I'd say the majority of new stuff written this year that I'm seeing is written in Go. Why is that? So I actually went and I learned Go and I started coding it. And I discovered it's a small, fast, easy, quick-to-learn language that has it's quite nice modern features, and it's relatively fast to pick up and get something done with. So I think it's a very productive new language for building system software. And it's got Google behind it, and there's a lot of people using it. So that's worth looking at. The next thing is, Jez, how's that book coming along? Be out by the end of the year. So the Lean Enterprise book really summarizes everything I've been talking about here. This is enterprises adopting continuous delivery, DevOps, and Lean at scale. That is what I'm seeing happen, and the book keeps being rewritten, and you can get like a PDF version of it, but you can't get the paper version of it yet. So I've been pointing people at this book for since late last year. So Jez is beavering away trying to finish it. And the other thing is really just this move from monolithic services to microservices. This is becoming a hot topic. If you look at anything to do with Docker, people are talking about microservices. Some of you may have heard of Workday. That's HR software, right? It's a SaaS platform for HR software. I read an interview with their CTO, I think, or CEO. He said, we're taking this software and we're rebuilding it all as microservices, and we're copying the Netflix model, and we're running chaos monkeys against it. And this was in some business, Forbes article after talking about all the business stuff. It's like, wow, we finally, the ideas do get purchased. People are paying attention. So that's really cool. All right, so I can take questions, and here's some videos I've done. So I did Monitorama is much more about monitoring. There's a few other talks that are somewhat similar to the one I've just done. I'd like to highlight this one, the DevOps Enterprise Summit coming up in about 3 weeks. This was amazing. I was on the program committee for this. I'm on the program committee. We said, we want the big old enterprise companies to tell us what they are doing with DevOps. And we got 170 or something submissions, some huge number of submissions from banks and insurance companies and government departments and big old complicated companies that were internally trying to figure out how to do DevOps. And we've got them all on stage. There's some amazing presentations, and I think this is going to be one of those conferences that just it's an eye-opening event to see what people have done. We basically ended up excluding just about all the vendor presentations. This is just end users talking about how they are actually doing this, but it's They like to say instead of the unicorns like Netflix and Etsy and whatever, we're the unicorns of DevOps. We have the pointy horns. We're very special. This is the horses. It's like there are millions of horses and there aren't really any unicorns. So that's going to be fun. And those of you from Germany, I'm going to be in Berlin November 6th giving a version of this, so you can tell your friends to come along. And finally, reInvent. I've been doing versions of this talk for a while. I'm starting a completely new talk, which I actually have to start writing soon, because they're complaining that they want early abstracts. This is going to be on optimizing cloud, optimizing the efficiency of your cloud, and trying to figure out how to get your costs down and run it more efficiently. So that's my next phase of presentations that I'll be working on going forward. Okay. Any questions?
We actually don't have time for questions, but please vote on the app, and please give warm thanks to Adrian Cockcroft.
Right, thank you.